Hello and welcome to this tutorial on making a realistic coin-operated gas meter for real-time applications like games and virtual experiences. My name is Hannah Watts and I am a senior prop artist in the games industry. In this course, I'll be taking you through all the steps involved in typical prop creation, beginning with reference collecting and blockout, proceeding onto the high poly, then the low poly setup and the baking, and finally the texturing and presentation of the gas meter. I'm going to add a disclaimer that this course probably is not suitable for absolute beginners and will require some confidence in 3ds Max and Substance Painter, and at least a familiarity with Marmoset Toolbag. Throughout the process, I will be using some paid services like Megascans and 3ds Max scripts, but I will call these out when I use them. Part of the tutorial will be real time and other parts will be time-lapsed at varying speeds in order to keep the video lengths reasonable. With that said, it's time to get started. The first section, which will be right after this introduction, will be the reference collecting and blockout, so let's jump in. So when starting a project like this, I always recommend picking a subject you have some sort of interest in or connection with, but also aim to do something that you don't see a lot of. Unique props will help your work stand out from other 3D pieces on sites like ArtStation and social media as well. I usually spend, for personal projects, a good couple of hours on my research and reference collecting. Obviously, in production, you don't always get that luxury. You might only get 20 minutes or half an hour, but regardless, I definitely don't start an asset without some clear reference images. And reference collecting is an ongoing process as well. I sometimes require getting even more midway through, like the high poly or the texturing stages. Once you've decided on your prop, depending on what it is, the two places I recommend the most for reference collecting are classified ad sites such as eBay, Gumtree and Craigslist, and also online auction houses. Another good place is actually museums and historic archives as well. But going back to the classified ads, due to the fact that people are selling the items, you can usually find reference from multiple different angles, as well as different types of the item in question. So here's my reference board for the coin-operated gas meter that we're going to be making. I'm using PureRef to collate my reference, which you can download from their website. It is donation-based. And as you can see, I've got reference of multiple different styles of meter. This is because I always find it useful in not only informing my understanding of the object, but also because I can pull interesting things from different versions of the same thing. I also recommend trying to find blueprints of your subject, as these will usually give you the correct real-world measurements, making your blockout stage a whole lot easier. As with any 3D task, it's advised to start with a blockout first to ensure proportions and scale are correct. It also helps me mentally deconstruct the model, and I begin to think about how I'm going to break down and build the high poly. So first of all, I'm going to drag my scale man in, standard practice for this kind of thing. You have to assume that this is going to go in a real world environment, and so it should adhere to real world scale. Now I can refer to the blueprints I found. I'm going to start initially blocking in just a basic cube to act as a kind of 3D footprint, using the blueprints that I have on my PureRef board as reference. I'm then using the parameter fields to put in the actual real life measurements. This is an okay base, but I actually think I want it a bit taller, so I'm going to deviate from the measurements slightly. I need to block in the container at the back, so I'll duplicate the same cube. I can see now that the front one needs to be a bit thinner, or the footprint of the whole gas meter is going to end up pretty chunky. I'm just going to use the connect tool here to block out a curve on the sides of the container so that I can easily differentiate between the two shapes. Here I'm going to use the Swift Loop tool, which I have bound to N on my keyboard, to plot in where the depression for the display screen is going to go. I'm going to delete this chunk now and then just bridge the edges to close the holes. Because we've cut into the top bit, I'm going to use a separate mesh as a measuring tool for measuring out the two symmetrical capsule bits at the bottom half and the resultant inset in the middle as well. I can then use the lines that I've plotted out here to extrude these segments. I also want to get this curved lip here, so again I'm just going to delete this chunk and then extrude the edges out to form this corner bit. I'm just focusing here on trying to get the proportions of these contours right, as this is going to make constructing the high poly far easier. I need to turn the top of this extruded segment here into a slope, since that is a distinctive part of the gas meter design. I'm not too concerned with good topology or things being neat here, I'm just eyeballing the gradient. It's actually better to work a little messier for areas like this, so you can be quick about working things out. The cleanup can always come after the proportions are nailed. I want to get the slants in these parts in now. A very basic blockout, a white box, that wouldn't need this kind of detail, but I'm going to block it in so that I can work out the relationship between all the sloping edges in this casing. I also want to begin blocking in some of these small elements, like this dial area, as we want to make sure that the spacing of everything is nailed before starting any high fidelity iterations. I'm going to use the auto grid checkbox here so that I can just draw the box straight onto the surface. From blocking that element in and comparing it to my reference photos, I can now see that the tops of these extruded capsule segments need to be brought right down and the overall depth of the casing needs to be reduced. Here I'm just going over the proportions of everything, constantly looking at my reference. The inner corner here, this height needs to be reduced and I need to get rid of that 90-degree blockiness. Again, you wouldn't necessarily need to block in chamfers like this, but doing so here allows me to work out how this curved corner connects to the display screen behind it. And I can begin blocking in the dimensions of what will eventually become the hole for the screen. You'll periodically see me assign a grey material to things. This is only because I find having tons of colours distracting. And I do it with wireframe colours as well. More often than not, I'll have all the wireframes in my scene grey or black. Continuing here to work on the flow of shapes in this display area. It's worth working out the proper relationships here, as this is definitely going to end up a focal point at the end of the project due to the amount of detail that will be going on around here. With that in mind, I'm also going to block in the semicircular indent at the top of the display screen. I'm just going to do a super rough pro boolean for this. If you haven't worked with booleans before, don't worry too much, as I will be going over them properly in the high poly stage. I'm still not concerned about messy topology or anything here. I'm just wanting to get the shapes in. I think this indent is a bit too wide, so I'm going to grab the verts and thin it out. I'm going to start blocking in the pipe connectors now, as the pipes are another major feature in this prop. I'll use the auto grid feature to draw a cylinder on top of the container, and then use the symmetry modifier to mirror another onto the other side. Obviously, to do that, you have to make sure that the pivot is central to the container. The dial area at the bottom is still bothering me. I feel like it should be a little wider and closer to the capsule extrusions, as there's an analog gauge that needs to fit above it. And I'll actually now block that gauge area in so I can check that there's sufficient space. I want to spend a bit of time blocking in this curved area here that will house the lock mechanism. Again, it wouldn't be necessary for a blockout in engine or anything, but I want to block it in so that I can work out the spacing of detail in this area, as to only glance at the reference, it does look a little confusing. As with the circle indentation that we did earlier, I'm going to do a really messy boolean to combine the two meshes. I'm starting with a flat cylinder just to get the roundness of the point, and then I will extrude the shape from there before adding a shell modifier for some thickness. Next up, I'm going to draw out some very loose rectangles to act as the blockout for what will eventually become the key. Rotate it into place, and then I can start blocking out the padlock too. I had a search online for padlock measurements, but there seems to be a lot of different standards, so I'm just going to eyeball this. For the bar, I'm going to use a torus primitive and then add a slice halfway. And then grab the ends and extrude down, positioning it into place. With the front bit worked out, I will quickly block in the pipes with splines. For easiness sake, I draw out the overall shape with right angles, not bothering to introduce any Bezier curves, and then I use the fillet tool to curve those hard corners. I'll also refine the blockouts of these pipe connectors a bit to better represent the layers of nuts and bolts that we're going to need to make. I'll clone the pipe to the other side first, get rid of the horrible green, and then I've decided I actually want to plot out the size of the dial on the front of the casing so that I know how big to go when it comes to making the high poly. While I'm in this area, I'm also going to alter this gauge frame. I'd made the ends very rounded, but in actual fact, they look to be kind of spear tipped. So I just want to change that or it will end up bothering me. Although I've said a few times that I'm not concerned with topology, I do need to clean this bottom bit up, as I've noticed that the two extruded capsule bits also extend down on the bottom as well. And so I need to get that in or I'll risk my design being wrong. I'm just using the cut tool and snaps here to fix the edge flow. After continuing to refine this area just a touch more, I'll grab those two faces on the bottom and extrude them downwards, sloping them in so that they continue the curve. Because the top of the casing has asymmetrical detail, I can't rely on using the symmetry modifier. So therefore, I'll just detach that extruded group of quads that I just made and move the clone over to the other side so that it snaps to the other capsule and then weld the verts. One of the last elements that I need to get in is the additional metal attachment that is appended to the pipe on the left. I'm just going to use really basic cylinders for these, since the complex shapes and the cross-section design will come in the high poly. Taking a look at my overall blockout, I'd say we're almost there. I just want to add the extruded ledge going around the midsection of the container, since I do think it's important for the silhouette. And then lastly, something I almost forgot about, the circular rubber seal that sits inside the indent that we made earlier on. So I'd say that my blockout is kind of done at this stage. It certainly doesn't look pretty, and there'll be some bits that I find are slightly off in proportions when I come to make the high fidelity meshes. But I'd say what we have is a good jumping off point for me to be able to start pulling parts off and constructing the high poly.